Hi scholars, today you're going to be learning about representations and strip diagrams for multi-step math problems. So we did study this in the fall before winter break about adding and subtracting and representing it using strip diagrams. And so I'm going to just go a little step further on how to represent them and show you multiplication and division. So go ahead and copy this in your journal and then just put your pencil down and then watch the video, and then after the video pick up your pencil and then copy the notes. Hi scholars, let's look at TEK 4.5a. I can represent multi-step problems involving the four operations with whole numbers using strip diagrams and equations with a letter standing for the unknown quantity. So represent means to show using pictures. Multi-step problems, meaning you might do subtraction and then division, or addition and then multiplication, or something like that, involving the four operations. So addition, subtraction, multiplication, or division. Whole numbers using strip diagrams. Strip diagrams, they're the rectangles, and then equations with a letter standing for the unknown quantity. So there will be whatever you are looking for as your answer. You're going to put T for total, A for answer, J for James, however many James has, as the unknown quantity. So before I even begin with multi-step problems, I'm going to first start talking about each operation on its own and what the representation looks like, and then we will slowly combine. So let's get started. I want to talk about a simple math problem such as 25 plus 36 equals 61. We're not worried about a word problem right now. We are just concerned on how do you represent this in strip diagrams with a letter standing for the unknown quantity. So let's pretend this is what we're looking for. Okay, I'm just going to put a question mark for answer. So you basically have two parts. You are combining those two parts and you're getting your total. When you have two parts and they are being added, you put them next to each other. Okay, now because 36 is a larger number than 25, it would be a little bit longer. Okay, just by a little. So when I have 25 and 36 together, I am showing this top rectangle up here is the total of 25 plus 36. So this is how you represent just an addition problem. So instead of a question mark for the answer, I might put, T for total. It can just be T for total. Or if I say so-and-so has 25 pencils, she bought 36 more pencils, how many total pencils does she have? You can use the letter P. So-and-so has 25 erasers. She bought 36 more erasers the next day. How many erasers does she have now? You could use E for erasers. It doesn't always have to be the letter T. But just know that the letter represents what you're looking for. So now let's look at what multiplication looks like, because multiplication and addition go hand in hand. Okay, so suppose I have a multiplication question that says she has 4 bags with 25 pencils in each bag. How many total pencils does she have? Okay, so, think of a picture, 4 bags. Pretend these are all very close to the same size. 25 pencils in each bag. How many total pencils does she have? Okay, so what you need to realize is, even though this looks like 25 plus 25 plus 25 plus 25, it's also 4 groups of 25. And so when I look at this representation, I think of 25 times 4. Or if I'm given 25 times 4, I can represent it with 4 boxes of 24. Think about it. When you first learned multiplication, scholars, what's 4 times 3? You are probably told, well, I have 4 groups. Each group has 3 The total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You had to draw 4 groups and put 3 in each group. Same thing. You have 4 groups, you put 25 in each group. That's all it is. So this representation shows multiplication. You can do 25 plus 25 plus 25 plus 25, but like if the math problem says they have 4 bags of whatever, or 4 groups of whatever, or 4 classrooms with 25 students each, this is how you would represent it. So multiplication only and addition math problems only look very similar. They both have the same thing. Your groups are down here, or whatever you're combining, and your total goes at the top. So now we're going to look at subtraction and division. Suppose I have 95, 95 pencils again, and I gave away 42. How many pencils do I have left? Okay, so this is different because if I use the addition model, sorry, 95 is more than 42. If I use the addition model, this looks like saying 95 and 42 together make this number. When you know 95 is what you start with, 42 is what you're taking away, what is left. So essentially, if you think of fact families, it's 42 plus something equals 95, correct? Think about it. If you had 5 minus 3 equals 2, your fact family is 2 plus 3 equals 5, right? So your addition representation would be 3 and 2 equals 5. Does that make sense? So my subtraction representation would still be 5 up here. I'm taking away 3. What's my answer? You are taking the fact family of the subtraction problem and trying to put it as an addition problem, but you have another part missing. So if I had 95 to begin with, or let's put it this way, I'm going to just go ahead and solve, okay? So the answer is 53, okay? But this is going to be the letter P, okay? So 42 plus 53 equals 95. So if I were to do the addition problem, think about it. 42 would go here, 53 would go here, right? And then 95 goes there. But since it's subtraction, I have 95 total. 42 was given away. How much do I have left? That's all it is. You're taking the addition problem of that, the fact family as addition in that subtraction problem, and you're like, well, in the addition problem, 95 went up here. So if it's subtraction, 53 is what I'm looking for, so I take away 53. So in subtraction, you have a total already there. You're taking a part away of that total, and you're looking for the missing piece. So missing piece plus the piece that you have equals the total. So now let's look at division. So let's think about division. Let's say so-and-so had 48 pencils. She split it up among 8 groups. How many are in each group? Okay, so division looks a lot like subtraction, but it's also the fact family of multiplication. So I'm going to just go ahead and solve, okay? I know the answer is 6. So my fact family would be 8 times 6 equals 48. So I'm going to use that to help me kind of start my representation. So 8 groups of 6. Okay? Now, there's a total of 48. So 8 times 6, or 6 times 8, equals 48. Now, let's focus on the division. 48 divided into 8 groups. How much in each group? So I would actually erase this and put G for each group, or the number of pencils in each group, or whatever you want to call it. And so when you look at this, this is a division representation. You're starting off with 48 pencils and you are splitting it up into 8 groups. How many in each group? So division is the opposite of multiplication, but its representation is very close to subtraction. So what I'm going to do now is I'm going to put an addition and multiplication problem side by side so you can see them, and a subtraction and division side by side so you can see them. Okay, so let's look at an addition problem and a multiplication problem. So if I have 43 plus 21 plus 16, how do I represent that? Well, you have something in the 40s, something in the 20s, which is about half of that, and then 16. So 43, 21, 16. When you put them all together, you're going to get your total. Okay? Now, what if I had 21 times 6? I'm still looking for a total because it's 1, 2, 3, 4, 5, 6 groups of 21. And when you put them all together, you're getting a total. So notice how multiplication and addition representations look very similar. Now, this is only an addition question, so that's what it would look like. I will be going on about if it's an addition and subtraction question, or addition and division question, or whatever. So that will look a little different. But just looking at a multiplication and addition only, they are very, very similar. In multiplication, it's repeated addition, and then regular addition, it's just, your 3 different groups, or 4 different groups, or 2 different groups. Okay, let's look at this subtraction problem. You start off with 81. You're taking away 26. You're taking away 7. What do you have left over? So I'm going to show you what this looks like, and then I'm going to show you how it ties in with addition, but then also how it ties in with division later. So 81 is what I'm starting with. Notice this already does not look like the addition representations that I showed you earlier. Okay, then there's like a group of 26, there's a group of 7, and then the question is, what is left over? Now, if I did an addition representation, it would be this plus this plus this equals this. So let's just do that. L plus 7 plus 26 equals 81. So I would be solving for this, technically, right? So I would have to show this plus this plus this equals the total, which we know is 81. So I'll just put 81 back there again. So L plus 7 plus 26 equals 81. So a subtraction representation looks like an addition representation in this, but in the sense that we have the total already. So they're just flip-flopped. And then division, it's the same thing. You start with a total, and you have 4 groups, and you want to know how much in each group. So the answer is 10. We know that. So 10 times 4 equals 40. So if you think about it, 10, 10, 10, 10 equals 40. So these division and subtraction both start the same way, but then whatever its fact family. Okay, so first thing I want you to write is addition. And the basic addition representation looks like this. Okay? When you're adding something, you're adding parts. And so you could have an amount, plus another amount, you know, whatever. And you're going to get T for total. Now, you're not always going to have the letter T. The question might say, what could be the total number of cookies? And they'll put a C, and they're expecting the letter C to be there. Or they'll say, what could be the total number of books? And that would be B. So, but basically, you have parts and looking for the whole. You are given this, and then you are looking for the total. Okay? Now, I'm not going to talk about subtraction yet. I'm going to talk about multiplication. Okay? Multiplication is very similar to addition. You are looking again for the total. And the same concept. You have parts and you're looking for the whole. The only difference is you have equal parts and looking for the whole. The whole piece. So I could have 4, boxes of cookies. Each box has 15 each. How many total cookies do I have? So I know it's going to be 15 times 4. These are my equal parts. So I do 15 times 4, or I could do 15 plus 15 plus 15 plus 15. But you should know that the shortcut would be this, and this would give you the total number of cookies. Now remember, this could be the letter C, the letter D, the letter J, whatever, depending on what they're looking for. Okay, I'm going to continue with addition and multiplication, where it could be multi-step. I'm actually going to go on this side. Okay. Addition, multi-step. Okay, this, technically I should have just put 2 boxes and you add those together and you get your total, but I want you to see a multi-step version of it. Okay? You probably remember in the fall we had questions like, on Monday, and I'm going to use really small numbers just so you can understand the concept. They sold 73 tickets. On Tuesday, they sold 12 more than Monday. So the question is, what's the total T tickets that they sold? Okay? So here's the thing. A lot of scholars want to say 73 plus 12, and that gives you the total number of tickets. But the thing is, this does not say 12 tickets. Like, this is 73 tickets. This says 12 tickets more than Monday. So it's Monday plus the 12 to just show for Tuesday. Okay, let me show you what I'm trying to say. Here's Monday's tickets. Okay, I just put a letter M there to show you. That's Monday's tickets that they sold. Tuesday is 12 more than Monday. So if Monday is 73, Tuesday is going to be 12 more than Monday. So then you have your Monday, and then that's your representation for Tuesday, and then that's your total. Okay, I'm going to show you another addition multi-step. This one is very much like this. I'm going to just change it up. Well, actually, let's copy the exact same problem with one slight change. 12 less than Monday. Okay, so I want to know what is the total tickets. So if Monday is 73, Tuesday is going to be 12 less than Monday. So then Monday is 73 minus 12, and that's going to give me the Tuesday amount. So technically this box right here needs to be smaller than that box, because if you're taking away from 73, then that size needs to be smaller than the original 73. Okay, let's look at multiplication multi-step. Okay. So let's just say in the month of January, she sold 4 boxes, 12 cookies in each box. Okay? But then in February, she only sold 15 cookies, not even boxes. Okay, just 15 cookies. What's the total? And they'll put the C like that, cookies that she sold. So we know January is going to be 4 boxes with 12 cookies each. So 1, 2, 3, 4. There's your 4 boxes, 12 cookies each. But then February is only 15 cookies. So there's your multiplication multi-step with adding the 15. Okay? So I like to write out math problems that help represent it. So if there's 4 parts, 12 times 4, and remember whatever's in parentheses you do first, and then you add your 15, and then that's going to be your total cookies. So if you notice, addition and multiplication multi-step all have the total at the top. Okay? Now we're going to look at subtraction. So yeah, go ahead and turn the page. Let's look at a basic subtraction problem first. This is your basic. Like, you know how at the beginning we did a basic addition and multiplication? Let's look at a basic subtraction. So you have a starting point of the amount that you have. Let's just say 100 jumping jacks that you're supposed to do for the day. And you've done 74 jumping jacks. How many are left? Okay, you have your starting point. You're taking away some. You need to know what's left. Okay, whenever you think about what you have left, you're always thinking of a small piece. Whereas when you think about total, you're thinking like you have the parts and you're getting a giant part, like the total. But in subtraction, it's like you have the total, you're looking for the missing piece. So for your notes, you want to say you have the whole and taking away a part to find the other part. Okay, let's look at division. I'm trying to speed through these notes because I know you guys have already watched about 15 minutes. So let's look at division. Let's say she had 100 jumping jacks to do, and she decided to split it up among 4 days. How many jumping jacks is she going to do each day? So notice subtraction and division have a similar concept where you start with your whole and then you're breaking it down to find the missing piece. So in this you have the whole and find how many pieces or how many parts or how much in each part. Okay, so let me do a quick one example of each. Multi-step subtraction. Let's see. Let me try to brainstorm an idea. Let's start with, this has some addition in it though, but we're still going to, subtraction is our main thing. So there's an I Love Lucy episode where they win $300 and they had to go through all this trouble to get the money back, and so they decided that the money that they spent in trying to get that $300, they will contribute to that, and then what's left over, they'll split among each other. So like, I don't remember all the details, but I remember they spent like $50 here, $189 here. They spent $10 for this, and then $25 for that. So the question was, how much do they have left? So this is easy subtraction, 100 minus 74. This is multi-step subtraction, and we've talked about how you can add all the expenses, okay, $274, and then your main step is to subtract. And so then L equals $26. So that's how you can do multi-step subtraction. You don't have to do 300 minus 50, then take your answer and take away 189, then take your answer and take away 10, and then take your answer and take away 25. You can add up all of these, make it one big number, and then subtract it from 300. So that's an example for a multi-step subtraction, and this is very common when you're shopping or looking at your expenses for the month. You always have a starting amount, and then you have to take away what you've spent, what expenses you have, what bills you have to pay, and then that's how you're going to know how much you have left for the month. And then for multi-step division, a scenario would be she had $500 or 500 marbles or 500 pillows, I don't know, whatever. And she gave away this much, okay? Whatever she's left with, she split it up among 2 boxes or whatever, or 2 families or 2 closets or whatever. So the question is, how much are in each box? So step 1 would be take 500 and take away what's given away. Then you have 2 parts left, so you're going to do 400 divided by 2, and that equals 200. So the answer is 200 each. Okay, so you will be learning this more in the class and practicing, but I just wanted you to see how these are written out. So remember, addition, the total is always at the top, and subtraction and division, it's always like the pieces, the parts at the bottom that you're looking for. So anytime like you get a question on like your countdown, in fact I'm going to pull one up because there was one and I was really impressed. Most of you figured it out. There's representations, and you had to pick which one best represented the question. So Mr. Dalgo paid a total of $18. So that already tells you 18 should be at the top, because it doesn't say what's the total for all the food they spent. They're giving you the total in the beginning. So you know 18 is at the top. And then 3 large burgers and 1 small burger. The large burger costs $5. So you know that's 5 times 3. And then it says, what is the cost of the small burger? So that's what you're looking for. That's a part of the total purchase. So the answer is F, because that's your total. There's your 3 burgers, and then you subtract, you do 3 times 5, which is 15, and take that away from 18. That's going to give you the cost of B. Now, H and J are wrong because, again, total should be at the top, and the cost of a small burger wouldn't be more than what they spent as the total, okay? So the more you see these, the better you're going to get, but I just wanted to give you an introduction.